We're going to be doing a fluid structure interaction CFD simulation. So we'll have fluent as the solver, and we're going to be doing flow over a cylinder. So you'll have your inlet, here's your outlet. This wing is kind of like the cylinder body. Look at the cut plane and space clamp. We can see the flow is going to be coming through there and wrapping around and coming in and moving outward. So this is the solid in here, and this for demo purposes is just flow moving over a cylinder. Once we have the flow moving over the cylinder, um, we can gather the internal pressures from CFD, and we can, after that, then take it over to a static structural and gather the stress on the body from the internal loads after we have mapped the pressure forces. Okay, so fluent's opening up. Alright, so I've already set up the simulation, and I've already ran the solution to this. So here, if we wanted to plot the scene, you could see how the velocity vectors are moving over the cylinder body and moving downstream outward. So we want to take the pressure forces that are generated on this body from the fluid domain passing over the body and couple that with an FEA simulation. So with the FEA, we'll have this left side and this right side body fixed as fixed supports, and then we'll gather the internal loads on that are circumferential around the body. So we'll close this guy out. So after we've finished the CFD simulation, we gather the pressure load, then we drag and drop a static structural, and we'll come in here and we'll set this guy up. Okay, so you'll pick, this is actual structural steel, so you pick the material, and it will mesh this guy. And as you can see, there's a little void body right in here, so we can run our static structural analysis. As you can see, there's a fixed support on the inlet and the outlet face, and if this was a wing, you would put it on the edges of the wings, so you're gathering the internal pressure forces. And what you should be seeing is that when the internal pressure forces coming in, you would see the maximum deflection occur here. So that's what we're hoping to see. That's what we're expecting to see. So the biggest thing is importing the load from CFD. When you drag and drop the static structural, the imported load comes up. You'll have here, you'll be able to pick on the surface. So here, if you have a name, not inlet outlet, but your wall enclosure. So this is the internal feature for the fluid structure interaction. This is a one-way FSI simulation where we're feeding the internal pressure force. So here's your imported pressure on this surface. This pressure load is about 14.7 psi. Distributed load. Um, Now for your analysis settings, you want to make sure you have your large deflections turned on, or else you'll have your cylinder actually moving outward and inward. So make sure your large deflection is turned on. And then we can solve it. After you solve it, you'll have your equivalent stress. So you can see your maximum stress about 20 psi, and it's occurring in the middle of this guy. If you want to play this, you can see how the maximum stress is developed right here in the middle of the cylinder. And we could play with this. We could make it longer, shorter, just to get the point of how an FSI simulation works. Then we look at the total deformation. So as we apply this internal pressure region from CFD, and then we couple that with an FEA simulation where we have fixed supports on the inlets and the outlets, or actually on the ends, you can see where this is sort of buckling feature happening right here. So the maximum is 1 e to minus 7 inches, almost nothing. And we're able to capture this data through this fluid structure interaction simulation. And that's pretty much that. So you couple your fluent with your static structural. Yeah, you import your load, your pressure load from CFD into